In section 2.2, we're going to discuss polygons and circles. Our objectives: identify polygons and know their characteristics. Know parts of a circle. Understand symmetry. First definition is triangle. A triangle is a figure formed by how many non-collinear points? How many points form a triangle? Go ahead. I'm going to start calling on people. Okay. How many points form a triangle? Adam. All right. 3. 3 non-collinear points. A triangle has 3 angles and 3 sides. I would call this triangle ABC. Equilateral triangle. Equal means equal, lateral means sides. An equilateral triangle has all 3 sides congruent. There's an equilateral triangle. There's all 3 sides congruent. I show that with the tick marks. Isosceles triangle. Isosceles triangle has at least 2 sides congruent. So there's an isosceles triangle. The 2 sides are congruent. And we've got base angles here and there. And this is the base. Definition. Scalene triangle. Has no 2 sides congruent. Picture of a scalene triangle may look like this. No 2 sides congruent. Scalene. An acute triangle has 3 angles less than 90 degrees. Example, here, acute triangle. All 3 angles less than 90. A right triangle. A right triangle has 1 angle that is a right angle. If we label the parts of a right triangle, the side across from the 90 is the hypotenuse. And then we have legs on either side. Obtuse triangle. An obtuse triangle has 1 angle that is an obtuse angle. This is your obtuse angle. That's an obtuse triangle. Equiangular triangle. All 3 angles are congruent. Equiangular. I would show that like this. That shows that it's equiangular. A simple closed curve. A simple closed curve is a figure that lies in a plane and can be traced so that the starting points and ending points are the same, and no part of the curve is crossed or retraced. Some examples of simple closed curves. This would be a simple closed curve. No parts retraced. Starting and end points the same. This would be a simple closed curve, even though it's got lines for the side, line segments for the side. By definition of what we just defined, it's called a simple closed curve. Some examples of things that are not simple closed curves. That is not a simple closed curve. Why not? Brian? Yeah, it crosses. So that would not be a simple closed curve. And this would not be a simple closed curve. Why is that? Why isn't that a simple closed curve? Christopher? Yeah, part of it's retraced. All right, so those are those examples of not. Circle. A circle is a simple closed curve that consists of all points equidistant from a given point, called the center of the circle. So you've got a point, all the points the same distance away, make a circle. Parts of a circle. The line segment joining the center with a point on the circle is the radius. The plural is radii. Okay, you can also, when they say radius, it also is used to denote the length. So radius can also be a length. Radius is the length of the radius, is really what that's saying. Diameter. It is a line segment containing the center of the circle with endpoints on the circle. Diameter also, the word diameter also is used to denote the length of the diameter. Let's look at a picture of a circle This is circle O. It's got a diameter D and a radius R. Right, that's the parts of a circle. Polygon. A polygon is a simple closed curve composed of line segments. Adjacent vertices share a common side, and adjacent sides share a common vertex. Examples of polygons. There's a polygon. Quadrilateral ABCD. That's a polygon. Sides formed by line segments. None of the sides are crossed or retraced. It starts where the starting point and the ending point is the same. Common polygon is a hexagon. That's a polygon. All right. So, types of polygon and their sides. A triangle has 3 sides. A quadrilateral has 4. A 4-sided polygon is not a square. The general term is not square. It's not rectangle. It's quadrilateral. All right. A lot of times people put square or rectangle for the 4 sides. Pentagon is 5. Hexagon is 6-sided. Octagon is 8-sided. Decagon is 10-sided. Anything above 12 is just the number of sides dash gone. So a 13-sided figure is going to be 13 dash gone. 25-sided figure would be a 25 dash gone. Anybody know what a 12-sided figure is called? A what? Dodecagon, yes. 12-sided would be dodecagon. Quadrilateral. A quadrilateral is a 4-sided polygon. 4-sided polygon. Parallel lines. Parallel lines are lines that are in the same plane and do not intersect. Why did I have to say that they're in the same plane? Okay, so my arms are parallel here, right? They don't intersect. My arms don't intersect here. Are they parallel? No, but they're in different planes. So if they're in different planes, then they can not intersect, but they aren't parallel. If they're in the same plane and they don't intersect, they're parallel. Anybody know what you call lines that do not intersect but they're not in the same plane? Okay, those are called skew lines, and that's one of our terms. We'll get to it in a second here. Let's draw a picture of the parallel lines. Okay, to show lines are parallel, to show line L is parallel to line M, I put an arrow on the line that is parallel to the other line. Those arrows in the middle represent parallel. I could put 2 arrows, as long as they have the same number of arrows. Same idea as tick marks. Okay, so those are my parallel lines. I lost my example. Did everybody get that, or do I need to redraw it? Okay, so then I would, to write that they're parallel, I would say L parallel to M. The two things. You need me to give you a pass back to class?
Probably. I'm just studying all that.
Yeah, I better fill one out. So for L parallel to M, you put the parallel line symbol in between the L and the M. Let's just do a quick pass. Here's the skew line term I was telling you about. It's lines that are non-coplanar and do not intersect.
Thank you.
A quadrilateral in which all sides are congruent and all angles are right angles. What kind of quadrilateral would that be? Megan Perry? All sides congruent, all angles right. Eli, help her out. No, it is equilateral, but that's not what I'm looking for. Bryant?
Square.
It's a square. Okay. A square, all sides are the same, so we draw a square. We mark all the sides the same with the tick marks. We show that those are all right angles with the box. What is a quadrilateral in which all angles are right angles? Eli? Yes, it's a rectangle. Picture of a rectangle. Is there? Rhombus? A rhombus is a quadrilateral in which all sides are congruent. There's a rhombus. Is a square a rhombus? Yes, a square is a rhombus. Is a square a rectangle? Yes, a square is a rectangle and a rhombus. Are all rhombuses squares though? No, all rectangles, and we know all rectangles aren't square, okay? So know those relationships. A quadrilateral in which opposite sides are parallel is called a parallelogram. So to draw a picture of a parallelogram, I show the opposite sides are parallel. That would be a picture of a parallelogram. Then we've got a quadrilateral in which exactly one pair of sides is parallel. That would be a trapezoid. Trapezoid looks like that. One pair of opposite sides parallel. An isosceles trapezoid is a trapezoid in which non-parallel sides are congruent. Isosceles trapezoid. A kite. A kite is a quadrilateral in which there are two distinct pairs of adjacent sides where the sides in each pair are congruent. A kite looks like a kite. And there's two distinct pairs of adjacent sides congruent, and there's two distinct pairs of adjacent sides congruent. What about this? Is this a kite? Could I call that a kite? Yeah. These two are congruent. Those two are congruent. That's called a dart. In terms of a kite, it's a dart. Okay, reflection symmetry. Reflection symmetry is when there is a line along which a figure can be folded so that one half of the figure matches exactly with the other half. The fold line is called the line of symmetry. Or axis of symmetry. How many lines of symmetry does this triangle have? AJ. Okay, well, the third side is not the same length as the other two. These two are congruent. So how many lines would it have? Okay, go ahead, Jacob.
One.
Nope, it has one right here. That's the only line I could fold it along, and there be a line of symmetry. What about this square? How many lines of symmetry does it have? Mia?
4.
Yes, it has 4. 1, 2, 3, 4. Okay, this triangle is equilateral. Let's go back. This triangle is equilateral. How many lines of symmetry does it have? What do you think, Brittany?
3.
Yes, it has 3. Those are my 3 lines of symmetry. All right. Then what about the last one? How many lines of symmetry does it have, Luke? 0, right. It has none. It's a scalene triangle. All right, rotation symmetry. Rotation symmetry is when a figure can be rotated about a point less than a full turn so that the image is identical to the original figure. The point is called the center of rotation symmetry. It's the center of rotation symmetry. This picture is an equilateral triangle. All the sides are the same. So if I rotate this corner from here, this vertex from here around to there, right? that's going to be a 120 degree rotation. So you would say this triangle has a rotational symmetry of 120 degrees. What other rotational symmetry would it have? What would be another one that we could say it has?
240.
Yeah, 240. You wouldn't say 360 because that just takes it right back to where it was before. But those are the rotation symmetries of that figure. What would the rotation symmetries of a square be? Mia. 90 is one. What would another one be? Megan Burkemeyer. Okay, Jacob.
180.
180. One more. What would another one be? Right?
270.
Yeah, 270. Everybody get the idea? All right. That's the end of the notes.